Welcome everyone to our webinar on network design for FTTx networks, with a large part showing demonstration of the FiberPlanIT Designer tool. My name is Raf Meersman. I'm the CEO of Comsoft, and I will be taking you through the presentation part of this webinar. But of course, a large part of the webinar will also be a live demonstration of the software itself, and this will be done by Jonas Verstuift, our business development engineer for FiberPlanIT. So the agenda for this webinar, I will start with a brief introduction about FiberPlanIT and around the terminology for planning and design. And then we will dive into the details of the real design process for FTTx networks with the live demonstration parts of the FiberPlanIT Designer. Then I will conclude at the end with an overview of some benefits and values of our tool in this stage of the process, and we'll treat the questions and answers that you may have at the end. So the whole webinar is expected to take about 45 minutes for the presentation and demo part, and then the questions after that. You can ask your questions during the session whenever you have them by putting them in the Q&A window, and we will then treat them at the end of the webinar. Also, when you leave the webinar at the end, you will be presented with a short survey where we kindly ask you to give us your feedback on the session and on the content. And then finally, also in the days to come after the webinar itself, you can expect an email from us, which will also contain a link to the recording of this session, so you can share the session again with other colleagues who might be interested. So, first of all, now a brief introduction into FiberPlanIT. FiberPlanIT is the name of our software solution developed by Comsoft, who is focusing on supporting the FTTx network planning process. It's a unique solution that improves the planning process a lot. And of course, we will see in the rest of the webinar in detail how that is accomplished. But here you see kind of our promise that we can make with FiberPlanIT. That is that we have the functionality to make the FTTx planning process smart, fast and easy. Smart in a way that we have unique intelligent algorithms inside which will propose optimized design decisions. Fast in a way that a lot of the calculations are done automatically, so there's a high speed for the design process, and easy because the interface and the parameter settings, it's very flexible and easy to adjust. So with that functionality, we can actually lower the costs of your FTTx project and increase revenues, so in the end a project can become more profitable, and we will show with some numbers how we can accomplish that. FiberPlanIT is a tool that has been on the market since 2008 in different projects, and we have been involved in more than 80 projects now, with more than 25 countries across the whole world. And all our customers in those projects have already planned more than 40 million homes. So we can easily say that in this specific part of FTTx planning, that we are the world leader, and that it's a very well-proven tool in the market. So before we now go into the details of the tool itself, just a brief introduction on some terminology related to the planning and design, so that we can nicely locate where FiberPlanIT is actually targeting. So the first step in a FTTx project, we call it strategic planning. This is where you make the big business decisions on, the business case, how much you will invest in this project, how much revenues you can expect, but also which type of network to build and where to start building it, for example. So all of that we treat in an initial strategic planning stage. When the business case is positive, we will have a go for a first deployment, which will be then triggering the design process. The objective of the whole design process is to come up with a to-build plan, which will actually be a construction plan that someone in the field knows where to put the cables and how to exactly construct the whole network. Now what we are showing in green in this slide is one example of a possible step-by-step process to come to such a to-build plan. In this example, what we show is a first step, which we call initial design or high-level design, and which would be a step where you take your area and you try to come up with a first design for that whole area that is as good as possible and is as optimal as possible for that area based on an exercise you do typically in the office. Then in the next step, we foresee a field survey to take those take that design into the field and check if all the proposed locations of cabinets or manholes or places where your cables would cross the street, if that's from a practical perspective possible. So field survey will come back with some feedback, and then it's important to be able to fine-tune the design according to that feedback. Once the design decisions are final, the detailed design step is actually adding connectivity on a fiber level by introducing fiber splicing plans, adding labeling, etc., to really document the whole to-build plan. And then finally, of course, this to-build plan is a basis for the network that is really constructed in the field. And obviously in the construction, if there is any change, it's also important to capture that in your documentation. So there you need to document the as-built network so that you know exactly where the cables and all the components are geographically located. So this is an example and a summary of a full planning and design process. And what's now important to understand is that FiberPlanIT as a software is focusing on the highlighted steps in this slide. So we have strategic planning, initial design, and fine-tuned design. And of course, the interaction with field survey and detailed design is very important for a good end-to-end process. But this is where we are working together with other software tools, which can have solutions that can bring the design into the field on tablet for a field survey, or tools that are built to create detailed printouts and splice reports for the construction teams to work on, or also towards workforce management. So those are things we have existing integrations with existing systems, but with different systems depending on the requirements and the needs of the customer. So we in this webinar will now be focusing on the steps where FiberPlanIT is active, and in fact for this webinar specifically we will be focusing on the initial and fine-tuned design steps, because strategic planning is also supported with the FiberPlanIT simulator, but this was actually treated in a webinar we did earlier. If you would have missed that, feel free to reach out to us, because we can then provide you with a recording of that session as well. But the focus of the webinar today is completely on the design part of the process. So that concludes the introduction, and now we want to move really to the network design process and show you how the FiberPlanIT Designer can be used in those steps. So we start with the initial design. In this example with the step called initial design, the objective is in fact to make the decisions, the big decisions on the topology for a certain area. This means, for example, we want to decide where to put fiber concentration or fiber flexibility points. So that can be a cabinet or a manhole where you have some concentration, splicing, splitters, etc. For your fiber network. Another decision is on what we typically call clustering, or in other words, decide which homes you will connect from a given fiber concentration point, and on a higher level, which fiber concentration points to serve from a certain higher level concentration point or from a POP. And a final question is how exactly to route the fibers, cables and ducts through this whole area, where to put them either underground or overhead, and how to route them through this area. Just one comment before we proceed. We are referring here to a number of terms which are quite typical for FTTH or FTTx networks. But if you're not 100% familiar, there are always some changes depending on the countries we've seen. But if you are not familiar 100% with some terminology, we also have some good overviews and even a webinar and a presentation where a good introduction to the general terminology of components is given. And again, if you're interested, feel free to reach out to us and we can provide you with some more information on that. So in this webinar, we won't go into the explanation of all the terms, and hopefully you are familiar enough with them to follow what we are presenting. So just to give you a better idea about what we are talking in this initial design, just have a look at this. This is a part of an area. You see some streets, the black lines. You see buildings located in between the streets, and you see some points that represent the addresses in this area. Now, if you talk about deciding how to design this, how to make a plan for this area, it's already, yeah, you can easily see how difficult it is to decide, for example, where to start clustering homes, where to put your fiber concentration points. There are so many options, and in the end you want to decide really on how to divide them, considering both the capacity of your components, but also especially having a minimalization of the total deployment cost in mind. And that's very difficult if you do that manually, because if you, for example, start at the bottom left, you may make some decisions which will in the end also have an impact on decisions that you make higher up in the network, and which may then not have been optimal from an end-to-end perspective. Of course, this is just then an example of some clusters and locations of concentration points, but then the next level is even more difficult. That is the routes of the cables, where they cross the streets and where they can also share some trenches between different layers to save more costs. So, in order to decide on these aspects in the design phase, what we see as some challenges in the let's say former ways of doing this is that, first of all, if you give designs to multiple designers or areas to multiple designers, there's a threat that they may interpret the rules a little bit differently or use some different rules of thumb while designing an area, which can be not so good for the uniformity of these designs, and which then can be a problem later on in the operational phases of the network. Another part, as we mentioned, is clearly on the optimization of your choices to come up with the most economical plan, so you minimize your investments. And there's obviously also an aspect of the people who are doing this design, so the engineers, the design team, where you should try to be as efficient as possible to work both in a short time with this planning, as well as save some more costs there. Now, just to illustrate that a little bit more before we show in the software how to tackle those challenges, just a couple of examples. So here you see an example of an area that if you present it to three different designers, three different people with the same description of rules, for sure, this we have seen many times, you will get three different designs. And at first sight, they may all look okay according to the rules, and they may all look good in terms of decisions, but still each one will have made their own decision. So we clearly see here there's a threat of a lack of uniformity if you divide work across different designers, because they will make different types of choices. But if you dive further into this example, in fact, we recently organized a workshop which was at an FTTH Council conference in Europe, where we had a broad audience before us, where we presented these 3 designs for the same area and asked them to evaluate and give their feeling about what would be the best design. Now, you see that no one really had a clear preference, although a majority was for option C, just from looking at first sight what could be the best option. Now, the funny thing is, if you actually calculate the costs of these 3 designs, it turns out that this design number C is actually the most expensive one, and not just by a couple of percentages, but in this case it was in total 5.6% more expensive than the cheapest one, which was the option B. So this example, which is realistic and proven, clearly shows the potential and the importance of the cost optimization. And another specific example of an experience of one of our customers who designed an area of 2,500 homes. He compared an original design that he made with a full FiberPlanIT design afterwards, and came up with an improved result of 8%. So in fact, he could save around 200,000 euro on his project by considering the FiberPlanIT design instead of a manual design. So you see the potential also in relation to the investment levels for such a project is huge. And then a final word on that challenge about efficiency of design resources. So from questioning some of our customers and talking with them about the way they did the design work before they used FiberPlanIT, we have seen that when people were planning manually, so drawing the network like in a CAD system, and then documenting the fibers, counting fibers, and counting these volumes for deriving a bill of material, we see that on average you can reach about 1,000 homes designed per engineer per month. And of course, this is error prone. They may have missed a couple of fibers in a street, and also very unflexible. If it turns out your input missed a building, it's not so easy to adjust that again. A more recent way of planning these networks is using GIS systems, and there typically you already have a good level of automation. For example, cable objects could be created along a predetermined route, so could speed up the process already a lot, with some volumes that we have heard of 3,000 to 5,000 homes designed per engineer per month. Now, if you use FiberPlanIT in these stages of the process, in fact you can use, as we will see in the demo, a lot of automatic preparation functions and automated selection of locations, clusters and routes, which means, well, some of our customers have even went up to 50,000 homes designed per engineer per month. So that's a huge gain in efficiency. And if you look in more detail, in fact, you see they are spending still most of their time in the early or the first data preparation steps. And once their data is clean and ready for a calculation, in fact, they can easily, within minutes, create different results and different calculations, which also opens the door for easy scenario comparison and evaluating a lot of options, like we will see in the demo as well. So just to summarize that and quantify that with another real customer experience. So there was this customer who designed an area of 2,000 homes manually in 2 man-months. With FiberPlanIT, he was actually able to create such a plan for that same area during the training sessions within 2 days. So he actually could save 38 man-days on such an area of 2,000 homes, which in his case was an equivalent of about 15,000 euro only in terms of his engineering manpower costs. So that gives you a bit of an idea on the potential and the value of these solving these challenges. And now I would like to give the word to Jonas to show live in the FiberPlanIT Designer how to accomplish this.
Thank you, Raf. So let me show you how we make an initial design with the FiberPlanIT Designer. I have here QGIS open, which is an open source GIS tool, and I will use this tool to visualize all the data, all the GIS data, and the output of the FiberPlanIT Designer. For the demonstration, I have chosen an area where I have building information and address point information, and I have loaded also the street center lines for my area. So if I zoom in a bit on a certain building, you can see that some buildings are multi-dwelling units where there are multiple address points inside the building. So each address point should get one fiber connection. In the demonstration we will do an FTTH design, but it's also possible to do fiber to the cabinet or fiber to the antenna or any other FTTx design just by loading the appropriate locations of your demand points. So let's first start with some input processing for this area. So there are some functionality built into FiberPlanIT to help the designer with the pre-processing of his area. So the first step that we will do is create the possible trenches from the street center lines. So we have loaded the street center lines, and what we want to do is create all the trenches by the side of the road where we can route the cable. So now the FiberPlanIT Designer is finished with this job. So for each street center line we have created trenches beside the road. This doesn't mean that every trench that is created right now will be used for the cable routing. The FiberPlanIT Designer will optimize the cable routing and can use every trench that is available in this input. So it's just possible routes that can be taken that the software knows which he can use. As you can see, some streets are less wide than other streets. This is also part of the input processing step. So by just adjusting some attributes of my street center lines, I can assist the FiberPlanIT Designer to make smaller or wider roads. The next step that I will do in my input processing is merge my home points in the building polygon. What will happen right now is the address point data that I have for each building will be gathered into a single point because we will have a single entry point for each building. So the software has now created one address point, one demand point per building. And let me just switch off the original address points that we had. And let's check by identifying the demand point here for this MDU that this multi-dwelling unit now contains 23 homes. So it will receive 23 connections, but it will have a single entry point. Another useful pre-processing step inside FiberPlanIT Designer is moving the demand points to the building polygon border. So what will happen is the demand points that we have created will now be in a central location, but with this function they will be moved to the border closest to a possible trench, which reduces the lead-in that is created automatically. So now every demand point is closer to the street center line, so the lead-in will be shorter. The next step is actually creating our drop trenches, so our building lead-ins will be created automatically for each demand point in my area. So the street side trench will be connected to the demand point, and the cable can be routed alongside this road and come inside the building. So now each building has a lead-in, and we can also verify if we want to change some lead-ins or change some entry points. by just overlaying a satellite image. So as you can see here, there is a lead-in running through a building because this is the closest side to the road. But by just manually changing the lead-in, we can tell the software to use a different route to go inside the building. So by just clicking and dragging our lead-in, we can change this for this building, and we can also move already the place where the lead-in should enter the building. So we can do this for every building that we want to, and we can use satellite image to help us to decide where we want the building lead-in. I have done this cleanup step for the area already before the webinar. So let me just load this, this cleaned up area here. So now I've loaded a prepared area where I already have cleaned up some building lead-ins so that they are all correct. The next step in my process is creating crossings. So I want to let the software know all the locations where a cable could cross the road. So these are all created automatically, and like with the possible trenches, it doesn't mean that every crossing will be used. So it's just enabling the software to use these crossings, but as we will see when the design is finished, not every crossing in the design is used. So as I made some changes to my input, I changed some lead-ins, changed some demand points. I will now save all these changes so that they can be used to do a design. So now all changes are being saved, and then they are final to do design on this area, and my complete area will be ready. So now geographically my area is ready, so I've done all the pre-processing steps to start doing an underground design. So cables will be routed underground and everything, all the equipment can be placed. But I will also need to specify the rules to be used. So we use one specific rules and material for each design, and these rules can be shared between different designers to increase the uniformity of your designs. During our previous webinar around strategic planning, we have decided upon the best rules and material to use for our design. So once this is fixed, you can use this to do all your designs. In our rules and material are built up over different layers, and for each layer you can change the type of cables and type of equipment that can be placed, and also all the costs for all the equipment can be changed here. So here we have all the costs already pre-filled, and for our design we will do a point-to-point design. So not a PON but a point-to-point design. Now the next step and the most important step is actually doing the calculation. So I'm just starting the calculation here, and what it will do now is for each layer in the network it will decide which cables that should be placed, all the locations for the cables, all the equipment that should be placed, and will output a detailed bill of material. This will take about 1 minute, and while it's calculating, let me show you another design that I have prepared, which is a mix between underground and aerial. So for the same area I had some input pole locations that can be used for my aerial design. So again, with some pre-processing, automatic pre-processing steps, connections between the poles and from the pole to the building have been created, and in my rules and material I have specified that you can that an aerial deployment is possible. So let me just switch off my possible routes so that it's clear where the cables are routed. So again, like with the possible trenches in my underground design, all the possible trenches are created, but it doesn't mean that every trench is used. And the same applies to my aerial design. So I had a lot of input pole locations, but as you can see, not every pole is used. For example, here you have a cable going over these poles serving all of these homes, but here you have some poles that were in my input but are not used. So let me switch into another area. Here we did not have any pole locations, but we had some existing pipes there. So let me switch off feeder cable layer for now and show you the possible routes. During the pre-processing of the area, the trenches were created, but we had some existing pipes also as input, so there was some existing infrastructure available. And while doing the design, the software has decided to route the cable alongside this existing pipe because this is more cost effective. So this shows you that a lot more complex scenarios are also supported with the FiberPlanIT Designer. Let me now switch back to the calculation which is now finished. So here the software now has calculated underground design point to point for an area of about 2,000 homes. So what did the software do exactly? Let me switch off the possible routes to make it more clear. So the software has decided where all the cables should go, where the equipment should be placed, so a manhole should be placed or a cabinet should be placed here. And all the cables are routed back to the POP from the demand point. And let me show you, each demand point gets a single cable from the distribution point running here. So this is a single 2-fiber cable running from this drop point to the distribution point. And this is the case for each cable. So here we have a cable running in the same trench for this other cable and for serving this demand point. All of these cables are running back to our distribution point, and from the distribution point, cables are running back to our central office location. Now, the software has decided upon the most optimal central office location because I did not have any input central office location specified. But in most cases, you will already know where your central office can be located, and it's also possible to specify this and then recalculate and compare the costs of the two designs. So again, by just dragging and dropping my central office location and recalculating, I get an updated design where all my cables are rerouted and my bill of material is adjusted. So I did not save my changes just now. So my central office will be located here if I rerun this design. I have done this before the webinar, so I have prepared a design where I had an input central office location which is not at the optimal location, and we can compare the costs of these two designs. So with my shifted central office location, so reusing the input central office location that I had, this results in a cost of 2,100,000 euros. And with an optimal central office location, the cost will be 40,000 euros less. So this gives you a nice overview and makes it easy to compare the cost and the impact of the changes you made on your total cost. So let's load the design with our shifted central office location, so with the input central office location that we wanted to use. So as you can see, the central office location is now located here at the bottom, and all cables leave this new central office location and serve all the homes in our area. Next to this graphical representation showing you where all the cables should be routed, where all the equipment should be placed, we also generate a detailed bill of material showing you the volume of all the equipment, all the cables, all the splitters if you're using a PON scenario, that you can order to realize your network design. So let me open this bill of material. In the overview of our bill of material, we can already see the breakdown in different layers of our cost, and these correspond with the layers we had in our rules and material. So you can see the impact of each layer on your total cost. The total cost is of course also represented in this bill of material, and we have a breakdown in the deployment and activation cost. Also per home you can see what the cost will be per home passed and per home activated. Next to this global overview of our costs, we also have a detailed bill of material where you can see the volume per type of equipment that will be needed to realize your design. So for example, if we step into our feeder layer, we can see that 12 fiber feeder cable will be needed, and this a volume of about 1045 meters. The unit costs that you see here are also specified in our rules and material, and if we adapt this, then our total cost for our design will also change. So this concludes the part over the initial design. So with a few steps in a low amount of time, we have realized already initial design on an area of 2,000 homes, and we also get a detailed bill of material already.
Thank you, Jonas. So indeed, we've seen now this initial design being created live on this area in a very short time. Now moving to the next step, if you remember the process view, we said let's take now this initial design into the field and have a check whether all the decisions that are proposed are actually also possible. And then of course there may be some problems like cabinets or manholes being located at a place if there's for example a tree or a driveway which could block you from realizing it at that location. Now then one way of solving this would be to go into the field with your design in a kind of a tablet app and start redlining in the field to provide information back to the designer in the office on where the problems are situated and how this could be solved in reality. And then of course the designer, based on such redlining information, could go and adjust the design in order to incorporate those constraints. Now in a lot of projects we've seen that in these steps if there was already some optimization in the beginning, that often in this fine-tuning step, the optimization is actually thrown away or discarded. And that's actually not a good idea. In fact, what we are trying to do with the FiberPlanIT Designer is to allow you to fine-tune the design, considering those redlining, but still having a big eye on the total optimization within those extra constraints. So let's show, Jonas, how you do that with the designer.
Okay, thank you, Raf. So here I'm back in the area we designed earlier, and this is now an initial design that I prepared, and there's some feedback from the field in this design. So I've added a redlining layer where I made some notes for this demonstration to indicate which changes that needs to be done to our design. So for example here, as you can see, I've indicated that these two homes should be served from distribution point 40, which is this distribution point. So what I will do is I will adjust the polygons that are associated with this distribution point so that they are contained within this polygon. So again, by just simply clicking and dragging, I can adjust this polygon. So what I do is these 2 points will now be left out of this polygon, so they won't be served from that distribution point, and I can include them in a different polygon so that they are served from this distribution point. So then when I recalculate, all cables will be rerouted from this distribution point to these points, and trenching will no longer be needed here. Another remark in my area was that this distribution point should be placed further down the road. So probably this location is not suitable for a distribution point, so for to place a cabinet or a manhole. So what we will do is we will shift it to a different location. So when I recalculate, all cables will be rerouted from this location, and the feeder cable will arrive here as well. So I've done this before the webinar, so you can easily see the impact of these changes after calculation, and we can immediately see the impact on the cost of our design, and see the graphical changes as well. So this is the starting point we had. So we had a cost depicted here, and then with our changes that we made and our recalculation, this cost has slightly increased, about 150 euros. So probably a bit more trenching is needed, or some more cables are needed. Cable length should be longer to reach these distribution points or demand points. So to realize the changes that we did. So the change I did here was place this distribution point further down the road, and as you can see, what happened, the cable, the feeder cable coming from the point of presence is longer now and has been rerouted to serve this point, and all distribution cables serving the homes in this cluster coming from this distribution point also have been rerouted. The same has happened for these two demand points that are now served from another distribution point. As you can see, the trench here is no longer needed to serve these demand points, but the cable is coming from another distribution point, so they are still served. Also, if you have feedback from the field that there's some extra development in your area, so some extra demand points should be served, then you can also add these to your area, include them in a polygon so that they are served from a distribution point, and recalculate your design so that you have minimal changes to your initial design, and you don't need a lot of time to completely recalculate your design. So this concludes it for the demo part of the webinar.
Okay, thank you. So wrapping up what we've shown you in this webinar, well, first we took you through the initial design process and showed you, well, the importance of uniformity, optimization and efficiency, and also demonstrated how the FiberPlanIT Designer can bring a good answer to these challenges. And secondly, we looked at a fine-tuned design step where we reused FiberPlanIT Designer to optimize the design, incorporating the field inputs that came from a survey. Just some figures to recap of real-life examples of gains. So in the optimization in the initial design, we see savings of 4% easily and up to 8% in some cases, and even more, all depending, of course, of the basis you're comparing with. On an efficiency, we see, well, also quite a broad range, but from 3 to 20 times as fast in the initial design stages by the use of the FiberPlanIT Designer. And also, very importantly, the remaining optimization levels in the fine-tuned design, which of course has a direct impact on the network to build, so is also very important. So all of that together, I think, nicely shows that our promise of turning the planning into profit is really valid, and that there's a lot of profit and a lot of savings to be realized by introducing FiberPlanIT in the design process. And that's not only us who are saying this. Like I mentioned before, we have done projects in more than 25 countries with more than 80 customers, and some of them were also so kind to tell in general their experiences with FiberPlanIT Designer, where, for example, a designer company in Italy mentioned that before this introduction of FiberPlanIT, they were creating these high-level initial plans by hand, which was quite time-consuming and error-prone. And in fact, by introducing FiberPlanIT, they could do it much more faster and also more accurately. And also interesting to hear is that, in fact, they saw an increase of job satisfaction, because instead of spending their time in counting fibers and making sure they didn't miss anything, they could actually use their time to try out different scenarios and focus on the real, let's say, problem parts of the area in terms of making decisions for the design. Similar experiences with our customer at Opticable and at Enable Networks in New Zealand. So before we go to the questions and answers, then just some final remarks. In this webinar, we have shown you a scenario with a focus on fiber to the home, but in fact, in several projects, we have also done designs and calculations for things like fiber to the business, to the curb, to the cabinet, to the node, to the distribution point, to the antenna. So in fact, actually, like Jonas already mentioned, you can model any type of fiber network. Depending on your demand points, you will and your rules, you will get a different type of a design. And even for some projects, this can incorporate an analysis of the existing copper or coax network. So if you have an interest or a specific focus also on such scenarios, again, please reach out to us, because we can share some more information on a case-by-case basis around those options. And another remark that is very important, like we've shown, we have focused on a couple of key features that are a part of the whole planning process. But if you're also very interested in the end-to-end process, we can look at some demonstrations with partnering softwares where in fact we can support the end-to-end chain, including solutions to seamlessly take this data into the field, to add the detailed design information, or to link to workforce management. So a lot of more information is available. Just let us know if you're interested. So that concludes the general part of the webinar, and we have some time left for questions. So let's have a look at the questions that came in during the webinar. Jonas, I have a first question here. Can you distinguish between different types of surfaces? And also, for example, well, a related question to that is this question on can you treat directional drilling as a way of crossing a street? Can you comment on this?
Yes. So let me switch back to our demo view, so our workspace. In our input data, we had created all the different, let me just switch back here. Okay, so we have created all the possible trenches and crossings for our area, and you can specify for each street or trench or crossing what the subtype will be. So what type of road is it? Is it a dirt road or a concrete? You have to trench through grass, then the cost will change. And the subtypes that you specify in the input data correspond with the cost that you can specify in the rules and material. So let me just quickly open the rules and material. So in our rules and material, we can specify for each subtype what the cost will be to do a street side trench or a street side or a crossing. So I think this answers the question.
Mm-hmm. Yes, okay, thank you. There's another question here also related to the input, which is mentioning, can you use AutoCAD drawings as an input?
Yes, if they are georeferenced. We can use AutoCAD data. We can transform it to the file type that we use for our designs. Or if you have, if you're working on we can also use another platform. So one of our partners can support those files. So we can definitely work on AutoCAD files as well, or we can transform them to shape files, which is the file type that we use for within the QGIS designer.
Okay, I have another question here. I'm trying to group them a little bit, so this is also related to the input data processing. What about if in a few years there's a building where a single home was, but it is upgraded to a multi-dwelling unit? How can the software accommodate that?
So what I also already said during the field survey part of the demonstration, if there are some buildings added, then you can add these to your input and then do a recalculation. What you can also do is provide spare capacity in your cables, or require spare capacity for your distribution points, for example, so that you can accommodate for future changes as well.
Okay, thank you. Then there's a question here on more related to the design rules. Do you support GPON with cascaded splitting? And related to that, another question that is asking of whether you can configure a GPON network with a 1:64 split. And does that then give an optimal street cabinet location for such a scenario?
Yes, so let me open the rules and material again. For our demonstration, we did a point-to-point calculation, but we also support PON calculations. You can specify, so there's a lot of flexibility, and you could specify per layer which type of splitter you want to place there. So for each layer you can specify the type of splitter, and to answer the second question, for distribution layer you can also specify 1:64 splitter, and then the software will do a calculation and will place the distribution point containing this 1:64 splitter in the optimal location.
Okay, thank you. Let me have a look at some other questions that are coming in. So there's a question here on can you design a whole city in one time, or what is a typical size that you treat in one calculation?
Well, it all depends on the area and the rules that you use. But here we did a calculation of 2,000 homes, and this took about 1-2 minutes. Typically, you will do a calculation per pop area, so this can go up to 5, 10, 20,000 homes in one run. If you're talking about larger cities, around 200, 300,000 homes, you will typically split these up into different pop areas and do a calculation per pop area with the software.
Okay, thank you. There's another question that has come in. Is there a process to export a final design to a CAD software, for example, for municipal permitting? Maybe I can comment on that. So in fact, our output will be by default GIS files like shape files, or could be also even within Quantum GIS be transformed into database formats or standard GIS, but could even be brought into a CAD system for plotting or giving through in any format, either by creating a custom translation function, or what we have also seen in the past is that through some of our partnering tools, actually our results can be automatically loaded into systems that might have this functionality already inside. So there are multiple options, but this can certainly be supported. We have time for a few more questions. There are more coming in, but we may treat some of them after the webinar one-on-one. What is a typical learning curve for this program? So what we have seen in the past is that within 1 or 2 days,
of training and using the software, you can already come up with an initial design. So you can already start using the software within 1 or 2 days. So we have a set of training video material that can help you to get started, and we also provide additional assistance if needed. But typically it takes about 1 or 2 days.
Okay. And then as a final question maybe, there's the question here on what is the licensing types. Is this with perpetual licenses or time-based? So maybe I can comment on that. In fact, our software is licensed in 2 ways. We have what we call an area-based license, and we have seat licenses. So an area-based license is a license where you would actually buy a license for to use the software in a certain area or a set of areas. Let's assume you have, for example, 4 projects, 4 different areas, each containing 2,500 buildings to be connected. Well, then in fact you can buy a license for the designer where you buy it for 10,000 buildings, and you will then be able to use it across these 4 different areas. And once your credits are used, a next area would require you to purchase more area licenses. So this is works very well in initial stages and on a project-by-project basis if you want to make sure you invest in software if you have some projects or some rollouts going on. Of course, if your volume increases, it makes more sense to go to a seat license, where a seat is then linked to an active user in despite of the number of buildings he's designing. And such a seat license is a perpetual license model, so you buy it once and then you can use it for as many seats as you have across the time. So if you want a budgetary quote for your specific case, we are happy to do that. Let's then get in touch to share a bit more details of your project, your needs, and then we can set up a budgetary quote that you have an idea about the total cost for implementing this software. Maybe just one additional comment on this is we also have a special offering which we call a starter pack, and which is actually targeted to get you started. So in this starter pack you get access to these tutorial videos, you have access to our experts for a given number of hours, so that if you have an advanced question that is not in the tutorial, they can help you. And you have an area license for a first area of 1,500 buildings. And this whole package is available for normally €3,000, and now in March there's a limited time offer to sign up for that for only €2,000, in which case you would actually be designing your area up to 1,500 homes all the way in a couple of days and create already your results. So that's a special offer that we launched based on the area licenses. So there's a couple of more questions, but we'll reach out to the people who post them after the webinar to treat them individually. For the rest, I can just remind you of the fact that we will be sending a recording of this session shortly in the days to come, so that you can pass this also through to some colleagues, and that it would be very nice if you could fill in the survey that will appear after the webinar has ended. So for now, thank you very much for attending and for all the questions and your attention, and hope to see you soon at some other occasion, or to talk about your project in a direct call. So have a good day and hope to see you soon. Bye-bye.